welcome to the Cosmic Pie Podcast, episode number 31. I'm your host, Wayne Barkhouse, and today with me, as always, is
Robert Moore.
So, Robert, we have a very special guest today.
Yes, sir.
All the way from Alabama.
Alabama,
You know,
Florence.
it's almost as warm today here than it is in Alabama right now.
Oh, really?
Yeah, because we're supposed to hit around 82 degrees or so, or even a little
Okay.
bit higher. So, and that won't last long. This might be it until, next June or something like that?
Right.
But coming to us from Alabama is Professor Melvin Blake from the Department of Chemistry and Physics, University of North Alabama. How are you doing, Mel?
Doing great.
So what's the weather like? What's the weather like there, Mel? Just curious.
Little over 80 degrees.
Right.
See, similar to
I'm
us.
surprised. I've lived for a long time in Atlanta and grew up on the Gulf Coast, and have to say I'm surprised it's that cool yet.
Well, it's been coming and going. Like last week, we had days when it was a little over 90, and then it's dropping down. So you're starting to get into fall weather. The humidity's dropping, which is nice.
Right.
I personally can't stand the hot, humid weather. Not that I miss snow. Don't accuse me of missing snow, because that's not true either. But
Well, I was going to say, can we substitute your weather with our weather when we get to January?
Yeah, really.
I don't want your January weather.
We can't even sell that, Robert. Do you realize
I know.
that?
I know. I wonder why.
Yeah, I wonder.
Yeah.
So, Matt.
Down here, when it snows, the whole city shuts down.
Yep.
So their idea of snow clearance is to wait for it to melt,
Right.
because they literally have no snow clearing equipment whatsoever.
Nope.
So that's in Florence, Alabama, if I'm
Yeah.
correct.
Yes.
Okay.
So so if we get 3 or 4 inches of snow, it basically cripples the whole city.
Yep.
Gotcha.
You see these people white knuckling it up the street, driving their cars at like 10 miles an hour because
They
No,
have
it's-
they have no choice. You know.
well, you can drive faster than that even if there's some snow on the ground.
True.
But but nobody has snow tires. They don't know to put weight in the back of their car to get better traction. They don't know any of these things. So
Right.
Right. So to be open, I guess, I've known Mal for many years. In fact, he was at my wedding. Believe that, Robert?
Yep.
Ah.
I didn't know Robert at the time, so Robert, you were not at my
No,
wedding.
I was not at your wedding.
I didn't know who you were. So.
Yeah.
But yeah, so Mal and I have known each other since our undergraduate days, and we went into the master's program at St. Mary's University in Halifax and did our master's degree. And then from there, we went on to Ontario to do our PhD. I went to the University of Toronto. Mal went to York University, so just outside or the northern part of Toronto, right?
Okay.
Yep.
And then we went on and did our postdocs, and now we're at separate institutions, obviously.
Yeah.
But Mal, I've talked a lot in the past. This is our 31st podcast, so clearly the last 30 podcasts I've had ample opportunity to talk about what I do in research, and it's reflected in a lot of the topics that we talk about in astronomy. And so no one, on this podcast has probably heard of you, Mal. So you want to enlighten everybody. What do you do as your primary research? What's your role at the University of North Alabama and those sort of things?
Okay, so you might see me get dark every now and again. My office has a timer switch, and if you don't move around enough, the light automatically comes off.
Got it.
So if you start to see me waving my hands in the air, it's to get the light to go back on. So that's what just happened there. But I have basically 2 main responsibilities here at UNA. The first is I teach in the physics program here. And so I teach undergraduate astronomy and physics courses. We don't have a grad program here, so I don't have to look after grad students. But I do research. My main area of research is variable stars. These are stars that change their properties over time in measurable ways. And so they can change either because we have stars orbiting each other. They can be pulsating stars, stars that have detonations in their atmospheres, and there's a lot of different things that you can learn about stars this way. Recently, I've been working on a project led at Athens State University which is a radio astronomy satellite. We're launching a little CubeSat into space that will study long wavelength radio waves that can't reach through the ionosphere. So besides research and teaching, my other main responsibility is that I run the planetarium and observatory here. So for instance, tonight we have a public tour night for the public to come and learn about the constellations. I'll talk a little bit about the eclipse that's coming up in October. And if the weather's good, and it looks like it is right now, we'll look through the telescope that we have at some things.
Cool.
So I'm the director of the planetarium and observatory, and I teach and do research.
So, Mal, how many people do you get showing up for a typical night that you're observing something?
When we have good weather, we've gotten actually much better attendance the last 5 or 6 months. I have some student volunteers that are helping me with the social media stuff, which is the main way people find out about things now. And we get anywhere between 25 and 30 on a good night. Our attendance, we can only seat 60, so getting half full is pretty good, because we can only fit about 10 or 15 in the observatory at a time. So
Right.
we're pretty pleased. About a year or so ago, we would have been getting 5 or 10 people, and our attendance is almost double or triple what it used to be. So I don't know if that reflects more interest on the part of people, or whether we're just doing a better job at getting the word out. I know the students are really helping, because they're much better at like Instagram and all this sort of stuff than I am. So
We had the similar problem in West Georgia when I was there, University of West Georgia. 5, 10 people would show up for our public observations. I've heard since they've gotten a lot more social presence that a lot more are showing up. So
one of my students just came in because she didn't realize class was canceled. So I was expecting that.
See, Robert, that's how important our podcast is. Mal managed to rearrange his schedule just so he can make our time.
Well, thank
see?
you very much. Yeah.
I did.
Thank you, yes.
Yeah, we do, over the course of the semester, we have to do 10 labs, but we have a 13-week semester. So you have room to, skip a week or two here and there.
Right.
So that's what I did this time.
Yeah, if any of you are watching, then feel free to send us a question through the chat that we have running. So we'll be able to answer that as soon as we see something pop up. Also, don't forget, we didn't mention at the beginning, but we are broadcasting from the campus, live from the campus of the University of North Dakota. But, if you know people who'd be interested in this type of podcast, feel free to let them know, and they can always watch it when we're not live. We're still alive, but we're just not live. You see how that works?
Yeah.
Right. Now, Mal, Mal, you mentioned the planetarium. So you have both the planetarium and the observatory. So do you have like regularly scheduled events at the observatory? And if it's clearly you can use the telescope. But if it's not, then you just have people in the planetarium and show them a show? Or how's that work?
Right. That's how it worked. When I first started working here at UNA, the way they used to do it is that they would just have observing in the evening. And so the planetarium was mainly used for school visits and for the astronomy courses. So what they would do is that they would have an observing night, and people would have to call if the weather was kind of iffy to find out whether the program was going to go or not. And I was picturing sitting down in the afternoon answering the phone, all afternoon. So what I did is I said, okay, well, let's use the planetarium for this. So I start off with a star show, what's up in the night sky, what planets, anything interesting coming up in the night sky. Then if the weather's good, we go to the observatory and look at some things. Tonight we'll probably look at Saturn and the moon. And if the weather's not good, then we show a video presentation. In planetarium business, they call them shows. It's basically a 20 or 25-minute video presentation. And so that way it guarantees that there's going to be a program no matter what the weather is. Of course, most people that show up in the evening, they want to look through the telescope. I mean, this is really, what they're after. And I don't blame them. So when we have poor weather, we tend to get less attendance than when the weather's good. Like today outside, today looks really good. So we'll probably have a good crowd tonight.
Excellent. I hope you do. I'm one of those that agree. You know, people want to put their eye to an eyepiece, and so that's the best way and the best thing you can do. So
Yeah, so here at our university, we do have public observing events. We do 3 per semester, where we get somebody who give a talk for about an hour, and then afterwards, if it's clear, then we take them outside. We have portable telescopes, usually like Dobsonian type of telescopes, set up outside to allow people to look at various things. And we time it so that the moon's at the good phase, that you'd be able to at least get the
Right.
moon if it's clear.
Pick the first quarter moon or something like that.
Yeah, something that works out. And we do it on Monday evenings because there are labs on other days of the week, and of course nobody will show up on a Friday night or a Saturday night. So, yeah.
I don't know. Here, one of the most common questions I get asked by people is if I do any programs on the weekends. You know, so I don't know. You might want to think about that. Of course, you don't want to give up your weekend, and if you've just put in a 60-hour week, then you know coming in on the weekend is a bit much.
Yeah, then you have to worry about whether you're allowed to come in and do stuff on a Saturday or Sunday when normally
Oh, really?
normally university's closed, so you'd have to get approval for all that type
Right.
of stuff.
Oh,
right?
really?
I'm sure you
Uh,
would.
They really don't pay any attention to anything I do. If I want to do something on a weekend,
Yeah.
go ahead. It's never occurred to me to ask permission to do anything on a weekend.
Yeah,
I know they don't like student workers to have to come in on the weekend.
Right.
So if I have someone working for me, then it has to be an exception.
I'm-
So, for instance, like October 14th, we have the partial solar eclipse. You know, it's an annular eclipse out west in Texas, in that area. But here we'll have a partial solar eclipse. And so, you know, the student worker that I have will come in that weekend to help out. But, you know, that's an exception because
That's an
you know, it's a
exception.
it's a special event.
I've got a question that popped up. I don't know if either of you will want to discuss it at this point, but
I have another student banging on the door.
okay,
I'll just mute for a second.
okay. And the question is from Wondergoon, and can we speak on the concept of tired light?
Yeah, so this is something we actually talked about a little bit in a past podcast. So
Right.
this notion of tired light, that's been around for
All right, I'm back.
Okay.
We're just talking about tired light. So this tired light business has been around for almost 100 years now. And it's a way of trying to explain what the redshift is, that it's somehow over time that light loses its energy, not because it's, went to lower or, lower frequency, a longer wavelength, but it just loses energy as it traverses large distance of space. In fact, we can test that, and there's no indication of any of the observations or experiments that people have done with light. And we know very well where light comes from. You think of the time of James Clerk Maxwell, the unification of electricity and magnetism. It's not mysterious,
Right.
You know,
right?
we've known it for 175 years now, something like that, right?
Yeah.
And so that's my point is there have been plenty of experiments and tests done to see if this tired light concept actually works, and the answer is no, it doesn't. So people keep trying to bring it back up to explain things, and it's like, no, it doesn't work.
Yeah, and you could do observations of really remote things, and if you think of the most remote thing that we can look at and get light, electromagnetic radiation, is the cosmic microwave background.
Right.
And there's no evidence, and looking at that in detailed analysis that we can do today, that shows there's anything that supports the tired light concept.
Yeah, I mean, it's the most perfect black body we've ever measured.
Exactly.
So if the tired light idea was real, that wouldn't be the case.
Yes,
Right.
exactly. So that doesn't work. But Mal, getting back, here's a question for you, Mal. What are you going to be doing on April the 8th of 2024? This April coming up, April the 8th.
April 8th for the eclipse?
Yes.
I don't know. I've been thinking about it. I've knew in the evening the eclipse track will pass through southwest Newfoundland, and I've never done a public outreach event in Newfoundland, and I've always wanted to go back and do some astronomy in Newfoundland, even if it's just for one event. And so I'm very tempted to get some eclipse glasses and do something, contact the university there and see what they're doing. and do something there. On the other hand, though, the weather forecast calls for an 80% chance of cloud. So, it might be a fool's errand, where, there's only a 20% chance that we'll have clear weather if we do something. The other alternative is that the eclipse track passes pretty close to us in southeastern Arkansas and that sort of region, and so it's an easy drive from here to get to the eclipse. I'm still toying around with it.
Right.
Either way, I'm definitely going to be doing something for it where I'm trying to watch it somewhere.
Okay. Now, did you see the one back in August of 2017?
Yes, that was spectacular.
So where were you for that one?
Well, it turns out a friend of mine lives in northern Tennessee and was about 2.5, 3 miles from the center of the eclipse track, and contacted me and asked me to come up and stay with them and watch the eclipse with them. So that's what I did. And we had over about 2.5 minutes of totality where we
Nice.
were. So it was spectacular. It was,
Yeah.
if you haven't seen a total solar eclipse, you really need to put that on your list.
Right.
Yeah, and that's really, that's an important point to mention, is I've heard anecdotes of people who were near the path of totality but didn't actually go there, and they said, you wouldn't believe it. The sun was like 99% covered. And,
Right.
and then you feel like crying. He's like, do you know what you missed by not going just a few miles to get to where it was 100% covered? Because it's should I use the pun, is a difference like night and day.
It
Yes.
really is. Yeah. I went to Knoxville for the last total solar eclipse. For this one, I'm planning on being in my front yard because my house is actually in Cleveland, Ohio, and it passes like a mile. The center line passes like a mile north of my house. So I'm
So
planning
you
on
can just hop in your car or walk over there.
right. I'm sitting on a lawn chair in my front yard, and because the center line there will actually be over Lake Erie. So. Yeah.
Well, that last eclipse there in 2017, we actually traveled down to Nebraska, myself and my family, and we saw it down there. And so we got this. That was the first one I've seen that was a total solar eclipse. I've never seen one before in my life.
Right.
Yeah.
And so this time I was thinking about, like you, Mal, going to the Maritimes, maybe go in like a Moncton area. So I have family lives in
Right.
Moncton and New Brunswick. But that's chancy on the weather. I mean, the closest point really for us would be to go down in Texas if you want a more higher chance or higher probability of better weather from where we are, right? But
That-
But if you're planning to go to Texas, book your hotel room now.
Yes.
Because I've heard that even like the 2.5-star hotels are starting to charge like $500 a night because the word is getting out that there's demand.
yeah.
And so if you're going to go to Texas in that area where there's a 90% chance of clear, then book now because they're starting to gouge people.
I might find myself in Cleveland for all I know.
Right. I've thrown the invitation open. I mean, we're in April. It's a good chance of it being cloudy, but at the same time, can't be sitting in your front yard watching it.
Sipping on Kool-Aid and watching the eclipse.
Do we want to take Wonder Goon's second question?
Yeah, do you want to start? So we have a question about the asteroid belt and if melted water from asteroids is safe to drink or will it be irradiated? So you want to talk about that irradiation business concept?
I will mention that one because, water is very difficult to irradiate. Radiation for the most part just passes through it. So the only way you can irradiate it and keep the radioactivity there is slow neutrons and turn it into tritium. But this is one of the reasons we use water as the absorber in nuclear reactors and in the waste pits, is because not only does it keep things cool, but it doesn't become radioactive with exposure. So, the water should be safe other than, any dissolved materials in it.
And there's a misconception here I want to clarify by noting that I irradiated water last night. And I did so by putting my supper in the microwave oven and turning it on.
Right,
And so far I haven't gotten sick from irradiated water, quote unquote.
right. So a lot of people worry about that, but it's really not a worry. Water that's been irradiated is just water.
Yeah, as long as you purify the water and there's no like hard elements in it coming from an asteroid, you got to clean it.
Right.
You should be able to drink it. And in fact, if you're surviving in the woods, I mean, you can clearly take water from a brook and drink it. You got no choice if you're dying of thirst. It's that or die, right?
Right.
Even though there might be stuff in the water that can cause you health problems later on. Hopefully you can get help and get to a hospital and get medicine to cure that issues. But you can imagine even a muddy puddle. If you're thirsty enough, you might filter that through your sock or something. You're going to drink it, right?
Absolutely.
So,
Yeah,
So-
I mean, if you've got the technology to get to an asteroid and harvest the water, then you've also got the technology to make sure that the water is safe before you drink it.
To pass it through a microfilter.
yeah, there's lots of
all of
things
that.
you can do
Exactly.
nowadays.
Yeah.
And unlike the days when we used to go fishing a lot in the summer when I was a young kid, you can buy survival things like a straw, it looks like, and you can suck water out of a mud puddle through that straw, and it's safe to drink. The water gets filtered enough coming out the other end before it enters your mouth that it won't cause you any harm. You can use it for several times,
So, yeah. Well, I mean, love the question because it is one that a lot of people bring up.
yeah.
But these are a lot of the problems that things like the International Space Station, where they've got people living in orbit. This is the sort of stuff that they're trying to solve is, if we're going to go to the moon or we're going to go to Mars or anywhere else, how do we do it in a way that we can use as many resources at the destination as we possibly can? Because carrying stuff into space and bringing it with you is much more expensive than just digging it up when you get there, right?
Right.
So this is all stuff that NASA is doing various projects to work on.
Mm-hmm.
Yeah, I mean, people sometimes relate, hey, we put up bases in Antarctica. Can't we just do the same on the moon and Mars? And yes, you can, but don't forget in Antarctica, you don't have to bring your oxygen with you,
Right.
right? You can melt the ice and stuff, right? Chip away at that. So
Exactly.
you can bring, yeah, so it's much easier to live in Antarctica by far, many times, orders of magnitude easier than to go to the moon or even on the Mars and
Of
so
course, I will argue the point that there's plenty of oxygen on the moon.
locked up in the...
It's locked up with
Yeah.
silicon because rock is primarily silicon dioxide. So the problem is pulling the oxygen off of that silicon atom, and that takes a lot of energy. So here on Earth, it doesn't make any sense to do that, but on the moon, it might.
Well, you must have heard, Mal and Robert, that there's an instrument that's running right now on Mars associated with one of the landers where they're generating oxygen. I think MOXIE is the name of the experiment, right?
Okay.
Yep.
So
I did
it's
not know
That's
that.
right.
yeah, so I
Cool.
mean, they're doing that now, generating. So obviously that technology will just improve in the future.
Right.
Yep.
I'd heard that there was plans to send one to see if they could make hydrazine, which is rocket fuel,
Right.
because then you can send that on ahead of your astronauts. It builds up fuel so that you don't have to carry enough fuel to get home.
Well, isn't SpaceX, they play around with methane in use of for the rockets, right? So if you can get methane extracted out of a planet, then hey, there's rocket
There's
fuel
your
right
rocket
there.
fuel.
So
Yeah.
and of course, if you have water, if you can extract water somehow, there's hydrogen in that molecule,
Uh-huh.
and there's oxygen. You just combine them in a different way. Once you separate them, boom, that's the fuel and the oxidizer source for the space shuttle main engines.
There you go.
Right.
So
So, it's a big thing with NASA and with other space agency organizations, I should say, to try to live off the land, as it were.
Yeah, the challenge is that it's one thing to do it in a little can on a little spacecraft, and another thing to do it on the industrial scales that they'll need to actually create enough fuel for a rocket, right?
Right.
So it's the scaling up factor that I think is the big challenge, right?
Mm-hmm.
yeah, we were born too early if we wanted to see this stuff in full development, right?
Yes, we were.
And we were born maybe 200 years from now, then maybe at that point enough engineering has been done that we'd see large amount of this type of stuff going on in different places within our solar system, right?
Absolutely. That said, we can see it from here, so I'm really actually annoyed that I likely won't be alive to see it done.
Well, that's another reason to take care of yourself and eat
Yeah,
well and
yeah,
exercise and try to live as long as you can to maybe see some of these things happening. But it's been frustrating, I admit. I mean, we were born at a time when, men had already landed on the moon before you were old enough to even know what's going on or before you were born. And then you're like, okay, if we keep going the rate we're going, by 1980, we'll be landing on the moons of Jupiter and Saturn, right? And it's like,
Yeah.
essentially almost none of that happened. And that's the political will and
Yeah.
the money. And
They just
so
kept
on.
going up and down to orbit.
Yeah.
Right.
Yeah.
And not even good orbit, low orbit.
Yeah.
You know?
Yeah. So, I mean,
This is
it's,
why I'm really happy with the Artemis mission that we're actually going to start going back to the moon
Right.
instead of just going up and down to orbit. And it's not like the space station hasn't done good work, because it definitely has. But let's explore somewhere, right?
Right.
And not with robots.
yeah, people make that argument, right? Let's just send a robot. It's a lot cheaper. It's a lot safer, right, to send to some planet. And I'm like, my argument on the opposite of that is yes, but it's not as inspiring, right? You can inspire people by sending humans to other destinations in the solar system, and then younger children get interested in STEM fields or education and want to know and want to do things with their lives just like they see other people doing things, right, that are older than them.
And
the other thing, that for long-term survival as a species, if we stay on the Earth, we're doomed.
we're doomed.
Eventually, a giant rock is going to hit the Earth, and that'll be it, right?
Or,
We'll be in trouble.
the
Whereas
sun's
if we've spread throughout different parts of the solar system, then a disaster in any one location won't wipe out the species.
right.
Right.
And so for long-term survival, you want to be living in different environments, for sure.
Right. I
Absolutely.
mean, Stephen Hawking made that argument as well as many other people in the past about doing that. And it's related to the fact that, the joke goes, if the dinosaurs had a space program, they'd be still here. And so you could think of, so someone might say, well, you guys are wasting all this money. Yeah, you're going in the International Space Station. They think, they seem to have a grand old time when the astronauts are up there. But do you realize the amount of billions and billions and billions of dollars that's put in the space station, in the space program? And it's like, yeah, but some year we detect an asteroid heading our way, and it's a global killer. It's not just a small little mass rock that gives a pretty meteor shower. Then the space program all of a sudden becomes a real good investment, you see?
Right.
Yes.
Yeah.
Yeah.
Yeah, I've seen and debated getting a nice T-shirt that has like a meteor coming at Earth, and it says meteors, nature's way of saying how's that space program going.
Yeah. Now, when we talk, now you mentioned about stars, and a lot of your research has been done on variable stars and so on. And one of the things that's kind of just, blew up in terms of the amount of research being done since the mid-90s has been this look for extrasolar planets. That's like a real cottage industry now. So what do you think about the whole idea? And along with that, of course, is the look for extraterrestrial intelligence, the type of SETI programs. Now, Robert and I have this slide that kind of illustrates some recent results on this, and I'm going to kind of give you the sort of the cliff notes of this slide here. So you can't see the slide, but everybody else will be able to see it. So it's a paper that just came out this month, September the 12th, and I don't know if you've seen it, was on AstroPH. And the title of it says, A Search for Technosignatures Around 11,680 Stars with the Green Bank Telescope at 1.15 to 1.73 gigahertz. And what they essentially did is they listened for a short period of time at a certain target, a star, and then move on to another one. And after a period of time, of course, they incorporate a little over 11,000 stars. And they can put limits, if they are actively broadcasting, which is a key point here, then we can put limits that we'd be able to detect these these technological societies, if they're broadcasting above a certain power in the radio, within a certain distance from us. So the limits that they put on here is that they can, detect things that are essentially out to about 100 parsecs. And they claim there was a revised version of this paper that just came out today, which we didn't have time to put in the slide. But now they're saying there's less than about 6.6% of the slides are producing radio waves that we would have detected here on Earth out to 100 parsecs.
Okay.
So, of course, less than 6.6 could be zero.
Right.
And so, Mal, as you know, there's been decades now since really the 80s when things started to ramp up, in terms of our technology of looking for extraterrestrial intelligence through detecting radio signals, and we just haven't detected anything. What do you think about that and what it means for the probability of life, not only elsewhere beyond the Earth, but how abundant do you think it is based on what we're seeing at this point?
Well, I don't think that they're asking the right question because, Homo sapiens, our species, has been around for about 7 or 8 million years, right? Assuming that you think people are intelligent, and I wonder that myself sometimes, but assuming that you assume we're intelligent, we've only been sending broadcast signals out for, let's be generous, 150 years, right? The first
Right.
telegraphs and wireless telegraphs and stuff, if you want to be generous, right? So out of a 7 or 8 million year history, you're looking at, less than 200 years of broadcasting signals,
Right.
right? So, that's not very much. And if he's thinking about, was it you said 100 parsecs?
Yeah.
So that's less than 200 light years, right?
Yeah.
Right.
So
So he wouldn't have been able to detect us if we were at the distance of the Earth.
right. So convert 100 parsecs. 1 parsec is 3.26 light years. So that's 326 light years.
Yeah.
So our signal wouldn't be there yet.
Yeah.
Right. And
So we would be there and he wouldn't have detected us.
and I will point out that our power levels would be so low that we'd be noise. And the same can be
So-
assumed. And now that we're broadcasting with enough power, the problem is we've become, instead of omnidirectional, we're broadcasting, with directional antennas.
Right.
So
And it
it's
assumes that broadcast signals are going to be desirable by another
Right.
civilization, which they may not. Maybe they get to the fiber optic stage and use that for local communications instead of using radio waves.
Mhm.
There's other ways that you can communicate over long distances, right?
Right.
So my feeling is that if we discover life elsewhere, number one, 3/4 of the population won't believe it's true. And the other is that it will be discovered by taking the signatures of the chemistry in the atmospheres of the planets and detecting imbalances that won't occur in nature. Things, like our atmosphere, if you took a good spectrum of it, you're going to find the results of industrial pollution
Right.
that do not occur naturally in any way, right? So I think if and when we discover life elsewhere, that's how we'll do it, is through chemistry.
Yep.
And and we've got a galaxy with about 300 billion stars. Our discovery statistics tell us there's roughly 1 planet for every star. So now you're looking at, 300 billion planets. To suggest that at least simple life forms only evolved and arrived at one location
Right.
in the entire Milky Way is very unlikely. So to me, there's certainly life elsewhere, but it could be so primitive that it's not sending out TV signals,
Right.
right?
Yeah. Or it could be so far away that we don't have the ability to detect the signal by the time it reaches us.
No.
It's just too weak.
I mean, there's every indication that dolphins are every bit as intelligent as we are. The cephalopods,
Oh
octopuses,
man.
they're ridiculously intelligent.
Yep.
I saw a video presentation where they took a little octopus and put it in a jar, and the thing unwound the lid of the jar and got out.
Yep.
Like it was just like, I watched that a dozen times. It was
And-
just so cool.
And from what I've heard
So-
of that video afterwards, the octopus was annoyed and made it known that it was not happy with them.
So there's plenty of intelligences that don't send out broadcast signals.
Right. Did you ever see that TV commercial? It's quite old. It was a long time ago when it was playing. It's a UFO comes to the Earth, and they're just above the Earth's surface, and they look down and they see somebody smoking, and they say, "No intelligent life here," and then they wander off.
Yeah,
You remember
I've
that?
seen that.
Lord have mercy.
Yeah.
So there's different ways you can define "quote unquote" intelligence.
Right.
So-
Yeah. I mean, dolphins don't smoke. They don't pollute their own environment.
They do alter their own environment, apparently, though. So, with their hunting methods and things like that,
Right. But I mean, even if we detect, let's say we send up a sophisticated laboratory and land on the surface of Mars, analyze the rocks and soil, and we detect, bacteria type of stuff. How do you know that didn't come from Earth? Because we know there's been a lot of cross-contamination. We find rocks on the Earth. For example, a lot of them have been found in Antarctica, where it's easy to find rocks laying on the surface of the ice, that has the clear signatures that they actually came from Mars or even from other planets. I think even Mercury and Venus have been, suspected of having rocks on the Earth. So how do you know there's none of this cross-contamination that occurs when you look at things really close to us, like Mars and so on, that we're really talking about the same biosphere? It's just more extended than what we would naturally think.
Yeah, this is the transpermia theory, where life originated elsewhere and got to Earth. And it's not unlikely. The Milky Way galaxy is about 13 billion years old, and the solar system is about 4.5, 4.6 billion years. So there was the opportunity for life to develop elsewhere in the galaxy for, 8 billion years longer than our entire solar system has been here.
right?
And so the idea that material with life in it arrive from outside the solar system, it's not a crackpot idea. It's the trick is that how would you know? How would you know that it originated elsewhere and not naturally evolved in the solar system?
Well, one of the things I heard is that I'm not sure exactly what it is. It's related, I think, to RNA. That RNA has a certain handedness associated, just like we have left-handed and right-handed things. You think of neutrinos and these kind of
Chirality.
things, right? And that life here always has a certain handedness. So if we find life elsewhere that has the opposite handedness, then that clearly would indicate it did not originate with Earth or related to Earth at all. And that's how you'd be able to tell there was life independent of Earth had arisen somewhere else. Whether that's on an asteroid that's inbound to our solar system from elsewhere, who knows, right?
Nope.
But there might be a reason why it's got a left-handed or right-handedness, and so life elsewhere would have the same. And so then you're stuck with the same conundrum.
That's right, and we have no other independent sample of life to examine to see if it does have the opposite handedness, right?
Now, I got to admit, I'm one of those that speculates: would we necessarily have RNA and DNA as the building blocks of life?
Right.
And would something else, some other molecule that can exchange and replicate itself, not have born up? But until we find such a thing,
I mean,
who
people have
knows?
toyed with like silicon-based life because silicon is good at making bonds as well. Carbon is extremely good at making complex molecules,
Right.
which is why carbon-based life seems to be favored. But I've heard of people toying around with whether silicon might be a viable alternative. Most of the other atoms, though, just aren't very good at making complex bonds
Right.
that you would need for life.
Right. Wasn't that even an episode in Star Trek, the old version from the
Yep.
60s?
Yep.
Maybe.
And
Yeah, I believe
there
so,
was
right?
one with there was actually more than one with silicon-based life forms.
Yeah.
And the problem I hear is that it would take a lot lower temperatures because the silicon bonds, break apart under heating fairly readily. And so while you can get carbon-like molecules out of silicon, they take much lower temperatures than what we have here on Earth.
So you need a cooler environment.
Right,
Well, that would just expand the habitability zone, right?
absolutely.
When you think of
But-
that place, the Goldilocks region, for those who don't know, where you're not too close to the host star, that's too hot for life, or too far away, that's too cold. This would just extend it a little bit further away if you want cold
Right.
life in some sense, compare a cold climate to support that type of life.
Yeah.
Right.
And then there's the possibility that, I can't remember if it's nitrogen or it's the sulfur, could be replaced with phosphorus. And that would be an indicator that you're dealing with a different type of life.
Right. So Matt, one of the things that was kind of piqued our interest many years ago when you learn about it, or if you were around at the time, if anyone is listening is the experiments that were done on the early Viking landers on Mars in the mid 70s.
Mm-hmm.
And over again, every so often you hear about, because they had mixed results on the first set of experiments that were run, and the idea was you take soil, put it into a container, heat it up a little bit, feed in some food, essentially, to see if the microbes would, flourish in that environment. They would give off gas, exhale, essentially, and that would be detected by the experiment. If you have an increase of this gas, then we know that maybe that was a signal of life. The other thing and so there was a signal when it was first done, these experiments, but the thing that they discovered was, well, there are other geologic type of processes that could also give off gas, so you'd have the same type of signal. So that result was kind of dismissed. But every once in a while, and I know it came up even recently, that's why I'm mentioning it, where once again, wait a minute, not so fast. Maybe we jump to the negative conclusion, too quickly, that we should really kind of wait and think about this. Yes, we can't reproduce that same experiment, but we can certainly go back to Mars and do those type of analysis, or even better today than what we could in the 70s. So do you have any view of that, Mal? What do you think about those experiments and those results?
I mean, the experiments from Viking were ambiguous. There were people that worked out, because what they did is they took some of the regolith, dropped it in a container, put in some water, and then heated it up, and then looked to see if anything happened. And something happened. But all the reading I've done on it is that the consensus opinion is that, it wasn't an evidence for life on Mars, that there's other explanations. And as Carl Sagan himself said, you need extraordinary proof.
Right.
If you're going to make a claim of discovering life somewhere, then it needs to be very definitive. So Carl Sagan himself, who helped design the experiments on the Vikings, he himself admitted that, it was ambiguous. But part of it is that I think the scientists themselves very desperately want to find life elsewhere. And so that automatically makes you look at your data differently than if, you're, in the middle.
Right.
And so when you really want to find a result, very often you find that result or justify the conclusion whether you've really got the evidence to back you up or not. So I think you're right, Wayne, that we won't really know until we send people there and do very detailed experiments. And there's not to say that complex life even ever evolved on Mars. It may be microbial life, and so, the oldest fossils on Earth, are from algae.
Mm-hmm.
And so, and Mars was probably only habitable for, maybe 1 billion years after it formed. So that's not a lot of time. Complex life didn't happen on Earth that fast.
Right.
Right. So I think that on Mars, we're more likely to see the evidence of microbes or something, as opposed to, multicellular life happening.
Right.
Because there just wasn't time enough before Mars' atmosphere got too thin to have liquid water on its surface. The volcanoes stopped erupting, the atmosphere boiled off, and now there's nothing, right?
Now there's nothing.
I like to play once in a while devil's advocate.
Uh-huh.
And one of the things that, the reason why these results like the Viking experiments come back again, right, and people start noticing it, is right now, you probably know NASA and the European Space Agency are looking at putting together a program called the Mars Sample Return Mission. And right now, the projected budget for that is way overblown. Like they're spending billions and billions of dollars more than what they had figured initially. So people are starting to turn this eye towards NASA's budget for this project and say, what's going on here, right? Because they're worried about NASA taking money from other things like they did with the James Webb Space Telescope and other projects unrelated to Mars.
Although if you talk to the James Webb Telescope people, they will argue that no, we didn't take money from anyone else's budget, which of course is mathematically impossible.
Right. So I worry that this news comes out recently now because they know they're in trouble with the budget, the Mars Sample Return Mission, and what better way to get support would be to say, hey, do you know this result back in the 70s? It may have indicated the presence of life. We don't know, but one way to know for sure is let's go to Mars, pick up some of the material and bring it back to Earth and analyze it. Then we'll know for sure.
Right.
But like the Curiosity rover is already picking up samples that are supposed to be returned, right?
Yeah, the Perseverance rover.
The Perseverance rover, yes.
Yeah.
Is already picking up the samples.
Yeah.
So if they're not planning on going and getting them, maybe they should stop picking up the samples.
Yeah, they're caching the samples, but they could lay there for 1,000 years before we go pick it up.
Right.
Yeah. Yeah. We'll send a person to go and pick them up, right?
Right.
And I'll agree with a biologist friend of mine. I'm distrustful of there being current life on Mars because he pointed out something. Everywhere we look on Earth, there's life. And it's not holding on by its fingernails. It adapted to the conditions. So if there is currently life on Mars, I would not expect it to be this barely holding on type of form. It would have adapted to the conditions and it'd be everywhere. So
Well,
I'm one of those that's like, not necessarily so sure anymore that there's current life, but there may have been.
Well, it may be just not on the surface, though.
That's
I mean,
true too.
We know that Mars has probably at least some liquid water underneath its surface.
Right.
Some of the Mars Express, I think, with the ground penetrating radar, found some evidence for underground water on Mars. So it may be flourishing where it's flourishing, but not on the
But
surface.
not everywhere. Right.
Just
And
not on the surface.
That's a good possibility as well, which says, hey, let's do Armageddon and send a drill team.
Well, the thing,
Like one of the trace gas experiments found methane in
Right.
Mars atmosphere a few years ago, and that's generally associated with production from life.
Yep.
Because on Mars, I mean, the ultraviolet would be hitting it and breaking the molecules up.
yeah, exactly.
So
Yep.
I think they're still looking into whether there's seasonal variations, so I think it's tantalizing. Some of the evidence from Mars is very interesting.
Yep.
There's probably underground lakes because as you get towards the interior of Mars, the temperature will heat up, and so you could have groundwater. I mean, they've driven mine shafts on Earth, where they're looking for ore, and they'll find microbes living almost in solid rock, right?
Right.
Where there's groundwater.
There you go.
So
I'll agree with you there, but the people are looking on the surface, and it's like I don't think we're going to find it there.
yeah, I'm very skeptical about them finding anything but perhaps fossils, trace
Right.
fossils or something on the surface. With the almost no magnetic field, very thin atmosphere, you're getting bombarded by radiation from the sun. You're getting hit by cosmic rays and particles from space that would destroy molecules very easily.
Right.
It's pretty tough environment, and plus the temperature, of course.
Especially big complex molecules like would be necessary for any form of life.
Yes. So I'm skeptical about them finding current life on the surface.
Right.
But underneath the surface, there's definitely environments where liquid water would be able to survive.
Now, one of the surprising kind of speculation that came forth just a few years ago was the tie-in with the existence of phosphine discovery in the atmosphere of Venus, that was produced by biology of some sort. And so you had the speculation where things are floating around in the upper atmosphere, riding along with the global circulation of the winds. Think of little parachutes or balloons rolling around. That some people indicated that could be life on the planet. Now, since that initial result came out, there's been a lot of work done where people look and said, no, the data's not that great. The signal noise is pretty poor. And so there, plus other people said, well, you might be able to get that from non-biological activity as well. So it's just interesting. We go from a place like Mars, where, who never heard of Martians, right?
Right.
To now Venus, and no one ever speculated Venusians would be there. You know what I mean? Like that was such a different environment altogether that there'd be no chance at all. It's a real hellish environment being on Venus, but it just kind of shows you in some sense our openness of exploring a huge range of conditions and the possibility that life is completely different in a lot of respects from what we know and love here on Earth itself.
Well, this is why I think, the term Goldilocks zone and, habitable zone, which is another term for it, I think are almost out of date because, there's plenty of evidence for environments elsewhere in the solar system that are way outside of the habitable zone, the classical definition. You've got the moon Enceladus around Saturn, which is spewing off geysers into space. So it must have some form of liquid water. Jupiter's moon Europa almost certainly has a subsurface ocean. The asteroid Ceres, it looks like it's had at least some liquid water because there's evidence for cryovolcanoes on that object.
Right.
And none of those objects are anywhere close to the habitable zone.
Right.
So
Cassini even tasted the water that came out of those geysers on Enceladus and found it's not just water, it's salty water. So
it's briny sort of water.
which is what you would need.
Yeah.
Exactly. Sort of like what you would see in a salt spring out west, right?
Mm-hmm.
So I think you're quite right that we need to have a bigger picture.
Right.
I don't.
Of where we would find life.
Yeah, I don't think, Mal, we're going to know for sure all of the conditions that's conducive to the formation of life until we actually figure out how do you go from something that's not alive to something that's alive.
Right.
If I was to start my career over again and I wanted to be a biologist, that would be something I would try to explore because it's such an important question, right? How do you go from something that's dead, that's not living, to something that's alive? What are those exact steps that is required?
Right.
And we
But I've also heard biologists themselves argue about what that definition of life actually is. Because I've heard people say that some of the fungi shouldn't be considered living. I think it was fungi. So there's some debate over the definition of what life is. I've heard people argue that some of the viruses shouldn't be considered life because they require an actual living cell to take over and reproduce.
Right.
So I've heard people argue that viruses shouldn't be considered a life form. So it's not an easy question.
And we do have another question. Gentleman Mike Worthy is pointing out that thermal pools in Yellowstone host life at higher temperatures. Could this expand in areas on Venus? And the answer is, yeah, I would think.
And we call those things extremophiles, right? So they're life that could live in really harsh conditions compared to what we need, like under extreme pressure, extreme temperatures, and it could go, hot or cold. And so we even had reports, you remember, what was it like? They found evidence possible of life and with a arsenic type of pools, you remember that, here on Earth?
Yes.
Talk about an extremophile.
Right.
And they've got subsurface vents where there's, the water temperature is, 1,000 degrees, and you've got living creatures living off that geothermal energy. Almost no sunlight reaches the bottom of the ocean near these vents, and they're able to use geothermal energy.
And then there's the methane yeah, those guys that have their own type of life around them. So,
Well, that's why you remember it was back in the time when Bill Clinton was president of the United States, where they had NASA announced, I think it was from the Johnson Space Center, I can't remember the PI on this research, where they announced the presence of nanofossils and a meteorite that was found in Antarctica that had chemical composition in terms of the gas pockets inside that was identical to what the Viking had measured when it tasted directly the atmosphere of Mars in the 70s. And they speculate these were nanobacteria, fossilized remains of bacteria that came from Mars. You remember that, Mel?
Yeah, I remember it was a big controversy at the time. People were saying, no, these things are too small to be bacteria and things like this. But the image was certainly
tantalizing.
Intriguing.
Yes.
Very intriguing. I think the consensus now is that they're not nanofossils, but I think there's still people that argue that they are. But certainly the best approach would be to go there and set up a proper lab and do it right.
And do it right.
Mm-hmm. Yeah, hence the feeling that we were born too early, right?
Right. No, I agree.
Because that's going to take a long time in the future probably before we get to that position. You can imagine we'll be investigating material from Venus, whether you send down robots that can survive better in that type of environment.
There's a proposed mission to use a balloon, essentially, to stay in Venus's upper atmosphere, which is free of the sulfuric acid.
Well, there's a private group, though, that is talking about doing this. Because I think Sarah Seeger is, there was an article in Sky and Telescope or Astronomy about this last month or the month before, how a private consortium that they put together is going to launch a Venus mission. And I think the first thing is going to be a probe that just sails through the atmosphere. But then they're already planning, I think, a follow-up where they'll use some sort of airborne balloon type thing to do longer sampling. So I think we're going to see some of that.
Yeah, I think NASA supported 2 projects to go to back to Venus, and I think one of them was kind of put on the back burner because of budget cutbacks. They were worried about that.
Right.
But is that private group? Is that the Rocket Lab business? The founder of Rocket Lab wanted ultimately to go to Venus.
I don't recall. I do remember that Sarah Seeger, big person in extrasolar planets, very famous scientist.
Yep.
I do know that I think she's part of the group. And it did have something to do with doing it quicker, because the NASA missions are going to be like a decade, right? And they're talking about doing it on a much shorter time scale.
Right. Along this whole avenue of exploring different places and ultimately looking for, areas that seem to possibly would support life includes Europa, as you mentioned, Mal. And the Europa Clipper is actually being constructed and built right now at JPL. Right. In fact, if you search after you're done reviewing this podcast and after you're done giving us a thumbs up and subscribing, then I encourage you to go to the search bar and type in Europa Clipper JPL, and you actually can see it live, what it looks like. They have live cameras showing you it being constructed, in California. You can actually see it. And in a couple of years from now, it's going to be launched and on its way to Europa. And when it gets there, I try to remember, was it 2030 or something like that to get there?
2031 or 32, I think.
Yeah. So you have to stay alive long enough to get the results back from that.
I plan on that long. So.
But the Europeans launched a mission to Jupiter this summer as well. So they're on the way. And I think their probe is going to get there around 2028 or 29, something like that, if I recall.
Yep.
Yeah, one of the most frustrating things that I found growing up and being interested in space exploration and so on is the fact that we can get to these places a lot quicker if we just used a bigger rocket, put in the money to invest into a better rocket to get you there faster, rather than taking the slow way of coming back to the Earth and then back to Venus and back to the Earth 3 or 4 times to get that slingshot to build up your speed.
What's $1 billion if you can get there quicker, right?
Well, that's it, right? We spend money on other things that I would argue are a waste, right? So, anyways, it's been great having you on this podcast, Mal. We're kind of going to wind it up, and I just want to mention, if you're interested in physics, if you're interested in any of the STEM fields, consider various places, including University of North Dakota. If you're in Alabama, I'm sure Mel wouldn't mind popping in at the University of North Alabama. If you're in Florence to have a visit, maybe taking a planetarium show if you're lucky to be there at the right time, and at the telescope and so on.
I post your podcast announcements on our Facebook feed, so I've been trying to help build your audience a little bit.
Cool. Thank you.
Greatly appreciate that. And speaking about the podcast, our next podcast would be next Tuesday, September the 26th, starting at 3 p.m. Central Daylight Time. And for all these podcasts, we always like to end with a quote. And this quote then is actually by Richard Feynman. In fact, there's a whole book of quotes by Richard Feynman if you're so interested in looking
I don't know if
up.
that's a good thing necessarily.
Yeah, some of them we may be able to say on the podcast, some of them maybe not so much.
Not
right?
so much.
So today's quote is, "People who wish to analyze nature without using mathematics must settle for a reduced understanding." So
like it.
thank you, Mal, for being
Thank
on
you.
the podcast. Thanks, everybody, to listening to this podcast and watching us, and we'll see you next time. Thank you.
Have a great afternoon.